The last 4 sections, we're going to do 2 sections from Chapter 9, 9.1 and 9.2. 9.1 and 9.2 will be on your final exam. 10.1 and 10.2 that we do next week will not be on the final exam. Okay, so we do them just as quick little sections for the end of the semester, but that material is not on the final exam. This last little packet you guys got, there's a few formulas on there, and there's also a table of values in the back that we'll be using for a couple little things too. So you will have that. Okay, so today we're going to start out review. Yeah. Yeah, so you're going to get on the exam that gold one and pink one that you had for the most recent test, plus there's a blue one that has all the other formulas that we used. So literally every formula, every table that you need, we provided. So know how to use it. Okay. So the study guide for the exam is actually already posted. If you look at next week's folder, there is a study guide. I'll get the copies of it to you probably Monday next week, the hard copies. And then there's also a practice test with solutions that's posted. And there's also, now that that's reminding me, a fun little bonus opportunity that I just posted yesterday too. It is Stats Clue. You have to figure out who's done it, and it is worth 3 bonus tickets on your final exam. So if you guys want to start looking ahead at that, it's like a digital activity where you go through 7 different sets of questions, and you find the answer to that question and do a puzzle in a different way. If you answer the puzzle correctly, you get a clue to eliminate suspects and weapons of math destruction, and then you can determine who did it. So that you have to solve the puzzle by, like, I think it was next Monday, and we'll have time when we review in class too for you guys to work on that. It's really like a self-driven review when we get to it. So but that's posted, all of that stuff. So if you guys want to look ahead at any of that, you can. Okay, that was a long answer to your question, Taylor. Sorry. Okay, other questions on anything right now? Okay, cool. All right, so we're going to start by reviewing with correlation. You guys did correlation. I mean, I know I for sure have taught this in like Algebra 1 before, so a lot of kind of repetitive topics from some topics that you've seen in the past before. We are, of course, going to expand on those a little bit, though. So correlation is the relationship between 2 variables. We like to look at trends in data as one increases, the other increases, or as one increases, the other decreases, that sort of thing. Our independent variable is going to be our x. Our dependent variable is going to be our y. And we, on this first slide, have a few different examples of correlation that you might see. So in that first one on the top left there, as your independent variable, as your x increases, as you go to the right, your dependent variable decreases. So we call this a negative linear correlation. And we're using the word linear because I can make a line of best fit that would show a general trend in that data. So what do you think the one on the top right is going to be? It's going to be a positive linear correlation. As one variable increases, the other variable increases. The one on the bottom, our data is kind of everywhere. So we can't really get a great line that would represent a trend in the data. It's really difficult to see a trend in the data. So when we see something like this, we say that it has no correlation. And then that final one, you can see there is a correlation. Our data is clumped pretty closely together, but it's not forming a line. What shape is that forming? Parabola. So if we want to get crazy, we could say it's a quadratic regression. But as far as what we do in stats, we're just going to say for right now it's a non-linear correlation. So there's some sort of trend in the data. There's some sort of relationship there, but it's not linear. That's all we know. Okay. All right. We use, I'm going to skip making a scatter plot. You guys know how to make a scatter plot. We're just going to go straight to correlation coefficient. We use a correlation coefficient to determine the relationship in our data. And right now, we're only going to be worried about linear relationships for our R values. You can, in other classes, talk about like quadratic linear or quadratic correlations or exponential correlations. There's other ones you can calculate. We only worry about linear ones. R is the correlation coefficient. There is a big formula for it, and we will be calculating this by hand. We'll also be doing it in the calculator. You probably did it in the calculator when you did it in a previous math class. R is pronounced, or R is called the correlation coefficient. P, if you see that, it's actually the letter rho, is how I would pronounce that. That's going to be the population correlation coefficient. So whenever you see an R, that's a sample, okay? And P is our population. So we're going to be getting a sample of data points. We're using that sample to find what the correlation in the data is. The range of your R values is -1 to +1. -1 represents a perfect negative correlation. So if you look at it, it's a perfect line, all your data points in a row going down from left to right. If you have an R value equal to a +1, that is a perfect positive correlation. So again, all of your data lines up exactly perfectly, but this time it's increasing from left to right. When we have no correlation, we end up right between the two. We have an R value that's close to 0. Then we have values that fall between 0 and -1 and 0 and +1. The closer you are to the extremes, 1 and -1, we say it's a strong correlation. The closer you are to 0, we say it's a weak correlation. Okay. You might see this called the Pearson coefficient. That's what this little blurb talks about here. That's where R got its name. That's the guy that figured all this stuff out. Okay. All right. Questions on any of that? Range of R's for now. We'll get to the formula in a little bit. All right. So I'm going to give you a minute. I want you to, for each of these sets of data that are graphed or scatter plots on the left, I want you to match the R values, and then I want you to also match the description of the correlation, strong, weak, positive, negative, whatever. And let's give these some letters. Maybe that is the easiest way to match these up. So let's say this is A, B, C, D, E, F. Okay. So for each graph, find the R, the Pearson coefficient, the correlation coefficient, and describe the type of correlation that it has. All right, let's check these. All right, so here's what I had. So graph A is an example of a perfect positive correlation, and graph D is an example of a perfect negative correlation. So 1 and -1 for those. If your data is going down, your R should be negative. If data is going up, your R should be positive. B is the one that is most all over the place. There's no trend in the data there, so that one's the closest value to 0. And even though it's not exactly 0, we would still say no correlation for that because it's relatively close. C is a negative correlation, so the only other option for that was that R equals 0.92. E and F, when you have to determine the difference between those two, F is again a little more clustered together, so that R value is going to be a little bit closer to 1 rather than E. You can still see it's going up from left to right, but it's a little more spread out, so we would say that's an example of a weak positive correlation. So 0.45 versus that 0.81, that's how you can tell the difference between those two. Okay, how'd you do? Good? Perfect. Great. Okay, so what we're going to do now is calculate that R value by hand. You will need a calculator for this, just to add up numbers. You know, a red calculator would be fine, but there's going to be a lot of summations that we're going to be using here. Okay. So when we calculate a correlation coefficient, an R value, there are two columns of data that you need because we have points now instead of just a single value for X. We have X's and Y's. So X's and Y's are our coordinates. You can make the scatter plot if you want to kind of get an idea of the trend of the data to start. To calculate R, this is the formula that you guys saw a second ago. There's a lot of little summations that we're going to need. A summation of X times Y, a summation of all the X's, a summation of all the Y's, a summation of all of the X squared values, and also a summation of all the Y squared values. So these 5 things are pretty much columns that we're just going to put next to our X and Y values. X and Y we'll have already. We're going to multiply the X and Y, add all those up. We're going to square all the x's, add all those up. We're going to square all the y's, add all those up, and then we plug everything into the formula to get our r value. So just a lot of kind of tedious calculations with this, but the math isn't super difficult. Okay, so here we have number of years out of school is our x, and then annual contribution in thousands of dollars is our y. It's the set of data that we're comparing here, trying to find if there's a correlation between the two. Okay, so for each of these columns, we're going to have a summation at the bottom. Okay. Sum, and a sum. All right, so I'm going to start by adding up all my x's. Again, this is just going to be tedious, so bear with me here. And I get 88. Add up all my y's. I get 56.7. Stop me if you see that I did anything wrong there, if I hit a wrong button. Okay, to get the next few columns now, I'm going to multiply for the third column the x's and the y's together. For that top row, I'm going to do 1 times 12.5, so that gives me 12.5. 10 times 8.7 gives me 87. 5 times 14.6, 73. 15 times 5.2, 78. 3 times 9.9, 29.7. 24 times 3.1, 74.4. And 30 times 2.7, 81. And then we add them all up. Okay. 12.5, 7, 73, 78, 29.7, 74.4, and 81. 435.6. Okay. Next, we take all of our x's and square them. That's fairly easy. The first few at least anyway. 1, 100, 25, 225, 9, I want to say 576. Yep. And then 30 squared is 900. Add all those up. $18.36. All right, square our y's. I get some decimals for this one. 156.25. 75.69. 213.16. 27.04. 98.01. 9.61. 7.29. Add them all up. $587.05. Okay. Now our R value, once you've got all of it. Big fraction. Okay, so first thing we need is our N. We haven't labeled N up here yet. N is how many data sets you have. So how many X's or how many Y's. So you can just count up your X's there. We have 7 points that we're looking at here. All right, so I'm going to start with that on my top. N is 7. Then I multiply that by the sum of X times Y. So that would be the third column. 435.6. Then I'm going to subtract the sum of the X's and the sum of the Y's multiplied together. The sum of my X's was 88. Sum of my Y's, 56 Okay, and I'm just going to go ahead and do that numerator real quick. So 7 times 435.6 minus 88 times 56.7. And I get negative 1940.4. Okay. Denominator, we've got 2 square roots, and they're similar. One's going to involve all my x's. The other is going to involve all my y's. All right, I'm going to start with n again. N is 7. And then the sum of my x squareds. So this is the 4th column. The sum of all your x squareds, 1836. And then we're going to subtract the sum of our x's and square it. Okay, so there's a distinct difference between the sum of x squared when there's not a parentheses, that's the 4th column, and the sum of x parentheses squared, that's the 1st column squared. So you have to be careful with the difference there. So that's going to be an 88. Okay, the second square root is going to be the same thing with the y's. So again, my n is 7. Then I'm going to do the sum of my y squareds, which is the last column, 587.05, minus my y's, that sum squared. Okay, so a lot in there, but again, we just type it in our calculator now. So you can do the 2 square roots separately if you want, and then multiply them together. Or you can do it all at once. Let's see, I'm just going to do it all at once here. I get 2137 point, I'm going to give it a few decimal places, 4989. And then my numerator divided by that. And remember, we're calculating that R value, so we should expect a number between -1 and +1. Anything else, we made a mistake. And I get -0.908. If I give it 3 decimal places, -0.9077 it was. Okay, so if you had to describe that correlation, would we say positive or negative? Negative. We would say negative. Would we say strong or weak? Strong. We would say strong because it's relatively close to -1. And then this is all linear correlation that we're calculating. There are other formulas if it's nonlinear, if it's a quadratic regression or a exponential regression. You guys might have done that in like algebra 2. You haven't done it by hand though. Okay. Questions there? Okay, it's tedious, but nothing crazy. All right, with your calculator now, let me show you how to check this answer. And we're going to do that on the next slide here. Okay, so first thing we need to do is go into our stat as usual. And we're going to go into edit and we're going to put our data in list 1 and list 2. Clear that out. 1, 10, 5, 15, 3, 24, and 30. 12.5, 8.7, 14.6, 5.2, 9.9, 3.1, 2.7. And then just make sure you have the same amount of x's and y's in those columns, otherwise you'll get an error in a minute here. Okay, good. All right, then we're going to go into stat. If we want to calculate something, we're going to go over to calculate. There's a bunch of regressions in here. The 1 variable stats is what we used before when we were doing all of our data or 5-number summary and our standard deviation. Use that on your project. We're looking at number 4 now, linear regression. And then you can just go down to where it says calculate. Your X list should say list 1 and your Y list should say list 2 here. Does anybody not have L1 and L2 there? That's all okay? All right. So go down to calculate, or just keep hitting enter. And oh, mine didn't give it to me yet. Anybody else missing their R? Okay, let's change a mode real quick. Go into mode. And we want diagnostics on. Mine must have reset. So if you go down to where it says Stat Diagnostics, on is what we want. So mode, Stat Diagnostics on. You only ever have to do this once. This calculator must have reset at some point. Okay, so let's do it one more time. Stat, calc, number 4, enter, enter, enter. And now you should see an R value there. And that's the one that we just calculated at negative 0.9077. It also gives us A and B for the line of best fit. That's going to be in section 9.2. We're going to be calculating that by hand. It's a little foresight to some fun. Okay. Any questions on calculator or by hand calculating the R, the correlation coefficient? Do you want to practice another one together, or do you think you got it? That's all I've got for you for today. Yes.
Why don't we just put in the cat like the giant one that we have here?
Mm-hmm.
Why don't we just put these in the calculator and skip things like that?
I agree. It is much simpler and honestly more accurate to do it with a calculator. But you are taking this test. So we are learning where those we come from this one Excel. Okay. I promise you there's going to be one of these by hand on your final exam. Promise. Okay, so definitely worth practicing when you do your math Excel. If you can do one and you got it and you don't want to practice anymore and you want to use your calculator, I totally get it. But at least try one on your own and make sure you're good. And then, of course, when you get ready for the final exam, you can do a practice test too. Okay? Good for today then? We'll wrap that up. Okay, so then tomorrow we'll do a couple more things with 9.1, and that'll finish this section for us. So you guys can take the rest of the period now. If you want to start on your Math Excel, you can. 9.1 Math Excel is due on the 3rd, which is next Tuesday night is your next deadline. And then you've got your project that's due on Monday. So if you want to take some time now, just work on the project a little bit more, that's fine as well. Okay? All right. We'll stop there. To be continued.